We live on a volcano time bomb. If it explodes, we are all doomed. Our planet is under constant bombardment by meteorites, asteroids, and comets. Fortunately, most of them are small and burn up in the atmosphere before they reach the ground. However, sometimes something gets through. And throughout history, these near-Earth objects, or NEOs, have caused some serious damage. Just ask the dinosaurs. But aside from the giant space rocks, there's another potential doomsday scenario that doesn't get as much attention. It comes from beneath our feet. Mount Vesuvius in Italy is probably the most famous volcano in history. It's also one of the most dangerous. More than 1,700 people were killed when it erupted and buried the nearby city of Pompeii in ash in 79 AD. But Vesuvius has been quiet for more than 2,000 years, right? Wrong. It's still active, and just a few months ago it made headlines when scientists warned that it could blow in the next decade. This is not just sensationalism. They think there's evidence showing that it could happen soon. There are many other potentially active volcanoes that could cause massive devastation. In fact, more than 500 million people worldwide live within 100 kilometers of an active volcano. So what would happen if one of them blew up? How would it affect the world? Would it trigger the end of the world as we know it? We already know that volcanoes can be devastating. The 1815 eruption of Mount Tambora in Indonesia is the deadliest in recorded history, claiming an estimated 92,000 lives. But let's look at a supervolcano. These are volcanoes that have had eruptions with a volcanic explosivity index, or VEI rating of 8. There have only been 7 confirmed historically, and 4 of them are found in the United States. Yellowstone National Park is home to the world's largest supervolcano. Its massive crater is 43 by 28 miles across. That's about the size of Los Angeles. While this dormant volcano attracts around 4 million visitors a year to marvel at its beauty, it could unleash unimaginable destruction. A super eruption here would send 2,800 cubic miles of ash and pumice into the air. For perspective, that's about 2/3 the volume of Mount St. Helens, which unleashed 12 cubic miles during its 1980 eruption. The force of the blast would register as a 9 on the VEI scale. If Yellowstone were to erupt today, it wouldn't just destroy the surrounding area, the entire country would be affected. Most of the ash would fall within 200 miles of the park, which includes parts of Idaho, Montana, and Wyoming. Some areas would receive up to 6 inches of ash, and that's not good. Breathing it in could be fatal. Plus, the fine particles could remain suspended in the atmosphere for months, blocking sunlight and causing global cooling. Even worse, pyroclastic flows could travel hundreds of miles from the caldera, incinerating everything in their path. Trees would be scorched, buildings turned to ash, even rocks and soil vaporized. And what happens when they come upon a river? The hot ash would melt the ice, creating lahars that race down the valley at 40 miles per hour, destroying anything in their path. Eventually, the lahars would make their way to the nearest cities, including Idaho Falls, Rexburg, and Jackson. Large parts of Wyoming, Montana, and Idaho would be completely destroyed. In total, 20 million people living within 250 miles of the park would be impacted by the disaster. Those further away would still experience earthquakes, volcanic tremors, and possible steam explosions. But what about the rest of the country? As the dust settled, people would begin to emerge from their shelters. Unfortunately, they'd find that nothing had changed. Without modern conveniences, their phones would be dead. No electricity meant no refrigeration, no air conditioning, and no clean water. Food supplies would dwindle quickly, roads were blocked, making it impossible for food or medical supplies to be delivered. They'd be trapped in their towns and cities until help could arrive, which might take weeks or even months. A 2018 study published in the Bulletin of Volcanology took a deep dive into the effects of a Yellowstone eruption. Researchers used computer modeling to determine how far ash would travel and how long it would remain airborne. Their findings were unsettling. Ash would blanket large portions of the western U.S. and even reach the East Coast. It would start falling almost immediately after the eruption and continue for several days. The researchers estimate that 8 inches of ash would fall in Salt Lake City and 6 inches in Denver. Chicago would get 2 inches and New York City 1 inch. But the effects would go beyond just the ash cloud. The eruption would likely lead to a nuclear winter, a term used to describe the cooling effect that occurs when large amounts of ash and gases are released into the atmosphere. Sunlight would be blocked, temperatures would plummet, and weather patterns would be disrupted. Crops would fail and wildfires would become more frequent, But the greatest impact would be on the electrical grid. Power plants would be shut down due to lack of fuel, but even if they could get fuel, they wouldn't be able to operate because power stations rely on water cooling towers to keep their equipment from overheating. These systems would be out of commission because, well, water everywhere, but not a drop to drink. In a best-case scenario, relief efforts would begin within 3 weeks of the initial eruption. National Guard troops would be sent in to assist survivors and search for anyone who didn't make it through the initial blast. Roads would need to be cleared so that trucks carrying desperately needed supplies could pass. It would take months for the country to recover from such a disaster. People wouldn't be allowed back into the danger zone for weeks or even years. Scientists would work overtime to monitor gas levels, making sure that it was safe for people to return. Meanwhile, the rest of the country would be picking up the pieces. Hospitals would run out of medicine and food banks would be emptied. Cities would struggle to maintain their water and power systems. The economy would be thrown into chaos. With agriculture disrupted and transportation halted, prices would skyrocket. Law enforcement agencies would struggle to keep order as people panicked. The eruption of Mount St. Helens in 1980 led to the formation of the Association of Northwest Steelheaders. After it wiped out fish habitat in rivers and streams in Washington state, this group advocated for the needs of steelhead trout and salmon. Today it remains one of the longest-running citizen science groups in the country. But while the U.S. would certainly be affected, it wouldn't be the only country dealing with the aftermath of a massive eruption. Countries all over the world would feel the economic impact. Global temperatures would plummet, leading to crop failures and widespread famine. Volcanic ash would travel thousands of miles, coating everything in a layer of fine sediment. What if the eruption happened in the summer? The intense heat could actually cause snow and ice caps to melt. Rising sea levels could inundate coastal cities, displacing millions of people. It's a scary thought, but it's not just hypothetical. It's based on real events that occurred 74,000 years ago. What's now known as the Toba Catastrophe theory holds that an eruption at the Toba supervolcano in Indonesia unleashed 2,800 cubic miles of ash into the atmosphere. That's enough to cover the entire United States in 6 inches of ash. Temperatures plummeted as much as 36 degrees Fahrenheit below normal. Human ancestors may have been wiped out, with only an estimated 40 surviving. But genetic studies seem to contradict this theory, finding little evidence of a population bottleneck around that time. It's hard to imagine how anyone could survive an eruption of this size. Entire forests would be vaporized. Landscapes would be scorched and covered in ash. Pyroclastic flows would rush through valleys, leaving behind a wasteland of solidified lava. But what if a supervolcano erupted beneath the ocean? Undersea volcanoes are common. In fact, the majority of volcanoes are located beneath the sea. They typically don't get much attention unless they cause problems for ships or underwater cables. However, if a large undersea volcano were to erupt, it could cause massive destruction. In 1815, a volcano off the coast of Indonesia unleashed 18 cubic miles of material. It wasn't the biggest eruption in history, but it was significant because it created a caldera nearly 30 miles wide. Underwater volcanoes can cause tsunamis, which are giant waves that can travel across the ocean at speeds of 500 miles per hour. When they hit land, they can cause catastrophic damage. The 2004 Indian Ocean tsunami claimed more than 227,000 lives in 14 countries. It was triggered by a 9.1 magnitude earthquake that unleashed the energy of 230 atomic bombs. The waves were as high as 100 feet, which is about the height of a 10-story building. Now imagine a supervolcano erupting beneath the ocean. The ensuing tsunami would be devastating. Entire cities could be wiped out, millions of people could be killed, and damage could extend far inland. Coastal communities would be inundated, forcing people to flee to higher ground. So, is there anything we can do to prevent a super eruption? Scientists closely monitor volcanoes around the world looking for signs of increased activity. They use a variety of tools like seismographs to detect earthquakes, which can indicate magma movement. Gas sensors measure changes in volcanic gases, which can signal an impending eruption. Remote sensing techniques like satellite imagery and aerial photography can identify changes in a volcano's shape or surface features. But despite these efforts, predicting when a volcano will erupt is difficult. They often give no warning, making it impossible to evacuate in time. Some experts believe that we might be able to prevent eruptions through human intervention. One idea involves drilling holes into the volcano and pumping water into the magma chamber. The water would solidify into ice, creating a barrier between the magma and the surface. Another approach is to use electric or magnetic fields to stabilize the magma. but these methods are still in the experimental stages and haven't been tested on an active volcano. For now, our best strategy is to monitor volcanoes and evacuate when necessary. The good news is that super eruptions are rare. The bad news is that we can't predict when they'll happen. So what should you do if you live near an active volcano? The first step is to be aware of the risks. Check with your local authorities to find out if you live in a high-risk area. Develop a plan with your family, including evacuation routes and meeting places. Make sure everyone knows what to do in the event of an eruption. And finally, pack a go-bag with essentials like food, water, and medicine. You should also have a plan for your pets. Don't wait until it's too late. Be prepared and stay safe.